Hello everybody, this is the workout example for you, and here I have used total elimination procedures to convert the CFG to CNF. Now this is the examples. One examples will given, that is here S produces ASB. This is actually given problems. You have to solve this because this is the production rules of CFG, and you have to convert these production rules to the standard CNF, that is Chomsky's normal form. Okay, so what we are seeing, that is S produces ASB, A produces AA, AAS oblique A oblique null, and B produces SBS oblique capital A oblique small bb. Okay, first step. What we have done in the first step? In the first step we have done that if we found the in the right hand side the starting symbol, the starting symbol is S in the left hand side, and if I found the similar in the right hand side the starting symbol, I have to eliminate this S by writing the productions. I newly introduce, I take the one variable S0 namely, so we will do this. S0 produces S. Now the production source will be S0. Just I eliminate S by S0. So S0 produces S, where S produces ASB, and the remaining parts is the same. Okay, this is the step 1. What we have used previous. This is step 1, previous rule. Now the step 2 previous. Now the step 2 rules. The step 1 rules, I think all of you understand the step 1 rules. Now come to the step 2 rules, where now we will remove all null productions. So the productions will be, you very much know about the null productions. So here I will use so according to the null productions, all of you have the knowledge in the previous class. All of you have the knowledge about the null productions. Okay, how to eliminate the null productions. So using that techniques, the productions rules without the null productions will be this. S0 produces S, and S produces this and this and this. A produces this and this and this. B produces SBS oblique capital A and oblique BB, and these production rules are without null productions. Okay, and without null productions. Okay, now removal of the next, the thing is the removal of the unit productions. And what we are seeing here, we are noticing that S0 produces S from the grammar else. So S0, from the previous example, S0 produces S. Okay, fine. So S0 produces S means capital A produces capital B. That means if we find this type of productions, so we have to eliminate this type of productions, and this is the unit productions, and this is the elimination of the unit productions. Okay, and for that what we will do, S produces S, S0 produces S. Okay, so from here we can write S0 produces this total right hand side elements. S0 produces this, we can add the new thing, S0 produces S, and S produces this one, so we can write S0 produces this one and S produces this one. From these two lines we can write S0 produces S, and this is the fundamentals of the unit productions. So we can just split this one into this one, and this one, and the remaining parts that A produces and the B produces is the same, remaining same here. Okay, also removal of the unit productions, S produces S. So here in the second line we find S produces S, and here S0 produces S. So from these two lines we just remove S, and freshly we can write, that means without unit productions we can write all the productions like this. Only you just don't write S and don't write S here, and just you copy this and write here. S0 produces this, S produces this, A produces this, and B produces this. So these productions are the productions without unit productions. Okay. Now come to the step 3. Step 3. What we have taught in the step 3, that is, if I found this type of productions, that is the mixture of the terminals and the non-terminals, then we have to split this. Okay. And here we find the in the third line productions with terminals and non-terminals, and also in the line in the fourth line productions, the mixtures with the terminals and the non-terminals in the right hand side, this one and this one. So we have to eliminate this in this way. So for this, we just S0 produces AS, ASB, will keep it remain same. Okay, we will keep it same. That is, in the right hand side here, no mixtures of the terminals and the non-terminals. In the second line also there is no mixture of the terminals and the non-terminals. In the third line, what we have found, it is AAS. So here we just introduce capital X newly and AS and capital X for this and capital. So here we use the capital X, which will eliminate X produces small a. Okay, small a. So from this line we can find that there is no mixture of the terminal and non-terminal. And from the fourth line, what we have introduced, the Y for the B, Y for the B. So this is SYS, BB, XS, XS, AA, and Y produces B. So we have replaced small b. We have replaced small b with the capital Y. So these production rules become the production rules without the mixtures of the terminal and non-terminal in the right hand side. Fine. Now here also one discrepancy is there, that is B produces BB. Here B produces BB. That means we also have to remove this type of production, that is the terminals, the total mixtures of the terminals in the terminals or non-terminals and mixtures of the terminals and terminals. That means here B produces BB. Here in the fourth line we find B produces BB. So we have to remove this B and B, eliminate this B and B with capital V and V. We have used 2 capital V. So this is possible, that is B produces B and B. Okay, but this is not possible. B produces 2 mixtures of the 2 terminals. So we replace the 2 terminals by the 2 non-terminals. So you have to just write B produces B. So this is the production rules without the mixtures of terminals and terminals non-terminals in the right hand side. Now come to the step 4. In productions rule S0 ASB. So we have introduced in the previous class that in the right hand side there will be no more than 2 variables. So here we find that 3 variables. Here we find that 3 variables. Okay. Here we find that 3 variables. So we have to just keep the 2 variables in the right hand side. So for that we have to eliminate this in this way. So here we use just in the first line for ASB. Here the number, we find the number of 3 variables, right? So we use the P. We replace AS as with P. Replaced AS with the capital P. So AS, PB, SB. Okay. So P produces AS, right? P produces AS. Where we will replace AS with the PB, and this is applicable. And here is only 2 variables in the right hand side. This is applicable, but not more than 2 variables in the right hand side is not applicable. So we replace this AS with the capital P. Okay. Now here also in the second line we find that in the second line we find that ASB, that the mixture of the three variables. So we have to eliminate like this. So here we introduced Q, and where Q produces AS. In the third line, XAS. Okay, we have to also eliminate this like the previous method, and we write A produces RS. Okay, RS and RS, and where R will be XA. That means R produces XA. We replace here XA with the R. Okay, so production rules will be, the production rules will be like this. And in the fourth line, SYS, that means an XAS. And so you have to introduce another capital letters and the variables. That means here we replace this by T, and T produces SY, and for XAS we just use here the U. So U produces XA, and so here these production rules at last become the production rules which is converted from CFG to CNF. This is the production rules we have after so many eliminations, and this is the CNF form. So this is the required CNF for the given grammar. Okay, I hope everybody understand my points. Okay, in the live chat platform, we'll interact with this. Thank you.